Hello everybody again. In the last session we used what we were creating here in our scene in order to connect Unity and have the robot being moved by the ROS planificator. In this session we'll go a little bit more in depth in how this works so that you can modify yourself. Um, so for the Unity part, the key file is here trajectory planning, which is added to the publisher as a script and accept as inputs the robot, the target placement. If we go looking to if we open the file in the solution, we will see that this is more or less like this. You see, this is the class definition. Those are things that initialize the file. And the core method of all these things is publish joint. You probably remember that in some moment we added publish joint here into the button. You will see that here in button we have trajectory planning publish joint. This means that once we click the button, this method will be called, and this method is indeed responsible for connected with ROS. What happens is that we create a service request. We push the current position of all the joints. Then we get the pose of the target. The target is the cube that you see the position and the orientation in quaternions. You would remember that from our deep dive, for every object, if we want to define position orientation, we need to use several values. This is exactly the same what we saw in theory. The same for the target. This is our cube, and this is where we want to go. So it is the target placement. Also, we have position orientation. We send this request to ROS using this line. This line accepts an additional function, trajectory response, which is a callback. Once this service finishes in ROS, it will return as a value, and this value will be interpreted in this function, which will print the trajectory returned and will execute the result of all the trajectory returned one by one. The execution is done in this part of the code. Okay, so much for this is the important part of the ROS or the Unity code. Let's go look very quickly to the Python code. For the Python code, it is contained. Okay, while the Unity code is contained inside your Windows machine or Mac machine in the folder that you choose, the Python code is contained inside the container. So in order to open it, you need somehow to map the directory of the container. You can do either inside the container or outside if you map the volumes. This is something that we can discuss together if you don't know how to do this. However, once you open it, you will see there are several directories, move it, Nirio move it, and Nirio 1, etc. And this structure of directory here is the same that we can see in the container. If we go, I'll close this because we don't need it. Okay, so we are in the container, and you'll see there is a source directory, and this source directory has the same code that we are looking here. So sometimes there is a problem when you run, just to make an example so you can orient yourself. Sometimes when I changed the permission in the server endpoint, what was happening is that this script wasn't executable. This is the main script that starts all the services, and was missing the execution bit. The script server endpoint is inside scripts and inside Nirio move it. So you find here inside source Nirio move it script server endpoint, you see. And here you see that I fixed the fact that it doesn't have the execution script anymore. It's just an example, just to see how you can orient between the container and the files outside of the container. So the file that we use to do the planning to connect to back and forth with Unity is here in mover.py. we will see that here, similarly to what was before, there are several methods and functions. The function that does the plan is called a plan trajectory, which reads the state of the joints, which set the target of the pose, where we want to go, and finally invokes the planner. The planner internally uses the direct kinematic and inverse kinematic that we saw in the deep dive in theory in order to find a way to move the tip of the actuator of the robot in our final position. In the end, it will return a plan. This plan will be, it is what is returned here in our Unity server. Okay, so for now, this is just a short introduction to how the code works. Have a look yourself and let me know if there is anything unclear, and or if you try to modify it, and if you somehow orient yourself. Okay, thank you for watching, and let's talk later.